So for this example, we have that 3x plus y equals 13 and x minus y equals 3. So we're going to try and solve this example using the elimination method. Now the idea of the elimination method is to make any one of x and y equal in both equations. So we can make our x equal in both equations or make our y equal in both equations. And then we combine both equations such that we are able to get rid of our x or our y's. So let's go with an example. In this case, our y's are already equal. We have y and y here. So that's basically 1y and 1y here. So we don't have to do anything. Now we have plus y here and minus y here. So how can we combine these two equations such that we're able to get rid of our y? We simply add them. In this case, we simply add them. So if we add our equation, if we add these two equations, 3x, so we're adding the equation in this case. So 3x plus x becomes 4x. But plus y minus y cancels out each other. And that's why it's called the elimination method, because we've eliminated y here. And so 13 plus 3 becomes 16. So now we've brought this down to the point where 4x is simply equal to 16. So now we can solve, and we can solve simply by dividing both sides by 4, such that 4 cancels out 4 here, and we're left with x, and 16 cancels out 4 here, and we're left with 4. So x is equal to 4. So now that we have that x is equal to 4, we can now put in x is equal to 4 into any one of our equations and get the value of y. So if we choose equation 2 here, now x becomes 4 minus y equals 3. So if we subtract 4 from both sides of our equation, minus y, it gets rid of the 4 here, and 3 minus 4. So minus y equals 3 minus 4 becomes minus 1. So the minus can cancel out minus here, and we have that y equals 1. So for this set of our equations, we have that x is equal to 4 and y is equal to 1. So let's solve another example. So for this second example, we have that 5x plus 3y equals 12 and 7x plus 2y equals 19. Now, unlike the previous example where our y's are already equal, in this case, neither our x nor our y's are equal. So we have to find a way of making one of these two equal. So in this case, if we choose to make our y's equal, now the most common way of doing that is to multiply through the first equation by the coefficient of the y in the second equation, and to multiply through the second equation by the coefficient of y in the first equation. So what I mean is, we multiply equation 1 by 2 because there is a coefficient of 2 here, and we multiply equation 2 by 3 because the coefficient of y in equation 1 is equal to 3. So if we do that, equation 1 becomes 2 times 5x becomes 10x, 2 times 3y becomes plus 6y, and 2 times 12 becomes 24. So for equation 2, 3 times 7x becomes 21x, 3 times 2y becomes plus 6y, and 3 times 19 becomes 57. Now we've succeeded in making our y's equal. So there's 6y here and there's 6y here. So the next thing to do is to find a way of combining these two equations such that we're able to eliminate our y. So how do we do that? Now we cannot add these two equations because if we have plus 6y plus 6y, that's going to give us 12y. So in this case, we would have to subtract both equations. So in this case, we subtract the equations. Now, if we have a negative sign here, you know that's going to affect all of our components here. So if we rewrite our set of equations, we have that 10x plus 6y equals 24. And now this is going to be minus 21 x minus 6y equals, the minus also spreads here, minus 57. So now we can go ahead and solve. So 10 minus 21x is going to be equal to minus 11x. Now plus 6y minus 6y cancels out. And 24 minus 57 results in minus 33. So now we have that minus 11x is equal to minus 33. If we divide both sides by minus 11, so minus 11 cancels out minus 11 here, and we're left with x, and minus 11 cancels out minus 33 here to give us 3. So we know that our x is equal to 3. So now we can take this and then substitute it into either of our equations. So if we choose equation 1 here, now 5, x is equal to 3, so that's 5 multiplied by 3 plus 3y equals 12. So now we have only y in our equation here, and then we can solve for y. So 5 times 3 equals 15 plus 3y equals 12. So 3y, if we send 15 over to this side, it's going to be equal to 12 minus 15. So 3y is equal to 12 minus 15 is equal to minus 3. And if we divide both sides by 3, so 3 cancels out 3 here, and we're left with y. And minus 3 divided by 3 equals minus 1. So for this set of equations, x is equal to 3, and y is equal to minus 1. And that is the answer. So don't forget the process. The process is, in this case, we chose to make y equal. So we multiply the first equation by the coefficient of y in the second equation, and we multiply the second equation by the coefficient of y in the first equation. Now by so doing, we'll make our y's equal here. Now because the signs of our y are the same in this case, we had to subtract both equations. Now when we subtracted both equations, we're able to get rid of our y and get a solution for our x. And then we substituted the value of our x in the equation 1. It could also be equation 2 as well, it doesn't matter. And then we're able to get a value for our equation y. So let's solve one more example using the elimination method to solve some simultaneous equations. For this example, we have that 6x plus 5y equals minus 2, and 3x minus 5y equals 13. So now, like we had said before, in order to make one of our components, one of our variables equal, we'll multiply the coefficient of that variable in the first equation by the entire second equation, and we multiply the coefficient of the variable in the second equation by the entire first equation. So in this case, let's go ahead and make our y equal. Now, to do that, we multiply through the second equation by 5, and we multiply through the first equation by the coefficient of y here, which is 1. So if we do that, our new equations become, because we're multiplying through by 1 here, equation 1 remains the same. So 6x plus 5y equals minus 2. Now for the second equation, we're multiplying through by 5. So 5 times 3x becomes 15x. 5 times minus y becomes minus 5y. And 5 times 13 becomes 65. So now, because the signs of our y here, which is the equal variable, are different, we can go ahead and just add our equations together. So if we add our equations together, we'll have that 6x plus 15x is equal to 21x. Now, plus 5y cancels out minus 5y. And minus 2 plus 65 becomes 63. So now we have that 21x is equal to 63. If we divide both sides by 21, 21 cancels out 21 here, and we're left with x. And in this case, 21 cancels out 63 to give us 3. So x is equal to 3. So now that we have a solution for x, we're going to substitute this into equation 1. So equation 1 becomes 6. Now instead of our x, we write our new value for x, which is 3, plus 5y equals minus 2. So 6 times 3 equals 18, plus 5y equals minus 2. So now let's make y the circular formula by moving 18 to this side. So we have that 5y equals minus 2. This becomes minus 18. And this is equal to minus 20. Minus 2 minus 18 equals minus 20. So if we have that 5y is equal to minus 20, if we divide both sides by 5, 5 cancels out 5 here, and we're left with y. And 5 cancels out minus 20 here, we're left with minus 4. So for this set of our equations, x is equal to 3, and y equals minus 4. And that's how we solve simultaneous equation using the elimination method. Now we're going to go ahead and solve simultaneous equations of a different kind. That's of the kind where we have a linear equation like we have here, and then it's a quadratic equation. So we're going to have a linear equation and a quadratic equation solved simultaneously using either of these methods that we'll just learn. And we're going to do that subsequently.